comes out of section 5.2, horizontal asymptote. Before we get into another specific example, I just want to talk in general about a horizontal asymptote. It behaves a little bit differently than a vertical asymptote in that it really is just describing the end behavior of your function. Meaning, if I've got a horizontal asymptote here, I may, come towards it and approach it like that. I may even have a couple of horizontal asymptotes where I've got one up here, one down here, and the graph approaches this one as I head towards negative infinity, and this one as I head towards positive infinity. That's a possible picture for a horizontal asymptote. A picture that sometimes students have a hard time wrapping their heads around is you can also have a scenario where you go past your asymptote at one spot, but then as you approach infinity, you approach that value. And so, unlike your vertical asymptotes, which stemmed from us talking about non-permissible values, values that the graph can never equal, horizontal asymptotes are not non-permissible values. What they describe is, as your graph approaches infinitely large numbers for x, or infinitely large negative numbers for x, what's your graph doing? And so it doesn't mean that you don't even cross. There's even strange cases where you could go above and below and above and below, but eventually level out to heading towards whatever this value happens to be here. So horizontal asymptote describes end behavior either to the left or to the right, but does not describe a non-permissible value. Now let's take a look at an example of a relatively simple function, and that is y equals 1 over x. Y equals 1 over x is an interesting, if I find the limit as x approaches infinity of 1 over x, the answer to that is 0. And it's also true that if you head towards negative infinity, if I put plus or minus infinity, if you put a gigantic positive or negative number there, this thing is heading towards 0. If you can recall what the graph of y equals 1 over x looks like, it does have an asymptote at y equals 0. It also happens to have a vertical asymptote at x equals 0, and does something like this. But specifically limiting our discussion here to horizontal asymptotes, the limit as x goes to infinity of 1 over x is 0. So now if I were to give you an example that kind of follows from this one and the last one, if I said evaluate this limit, x goes to infinity of 6x squared minus 3x plus 11 over 5x plus 9x squared minus 1, hopefully you would approach this by saying, well, the highest degree top and bottom is 2, so let's divide everything by an x squared. So the limit as x goes to infinity, here I've got 6x squared over x squared minus 3x over x squared plus 11 over x squared over 5x over x squared plus 9x squared over x squared minus 1 over x squared. And what you'll find is that you end up with 6 over 9, which you can reduce to 2/3. So if we were looking at that graph, whatever that terrible function would actually look like, since I just made it up, I'm sure the numbers don't work out nicely, but what it would have is at y equals 2/3, you'd have yourself a horizontal asymptote that your end behavior would be described by approaching that imaginary line.